Hello guys, welcome back to my lessons. Today we're going to talk about the topic of genetics, and we'll be talking about how a person ends up being a boy or a girl, right? And we're also going to talk about sex-linked characteristics, or what we call X-linked characteristics. So let's start with how gender is determined, right? How you end up being a girl or how you end up being a boy. What actually happens? So the question says that a couple has 3 sons and the woman is pregnant again, so we should show diagrammatically by means of a genetic cross what the percentage chance of the couple having a baby boy, a baby girl. So what you're going to do, you're going to write the sequence P1, and then after P1 you write phenotype, under phenotype you write genotype, under genotype you write meiosis, under meiosis you write gametes, under gametes you write fertilization, under fertilization you write F1, and then you write genotype and then phenotype. Right. So phenotypes is male multiplied by female. Male is the father, right, and the female is the mother. So let's write the genotype. So the alleles for the genotypes is XY. XY represents what? A male, and then XX represents a female. Right? So for your meiosis, you don't write anything, and then for gametes you write the genotypes as they are, XY, XX, but in the middle you put comma. For an example, X, Y, and then X, X. And then for fertilization, you write nothing, and then for F1 genotype, F1 is the offspring, the genotype of the offsprings, the genotype of the children. Right? So how do we get the genotype of the children? You take the first X of the male, the X of the male, combine it with the first X of the female. You get XX. And then you take the X of the male again, you combine it with the second X of the female, you get XX. And then now you're done with the X of the male, you're going to deal with the Y. You combine Y of the male with the first X of the female, you get XY. You cannot write Y before X. If you combine Y and X, always start with X and then after that write Y. Lastly, the last genotype is going to be, we combine Y with the last X of the female, and we're going to get XY. So what are the phenotypes of these genotypes? Is XX a male or a female? It's a female. XX, is it a female or a male? Is a female. XY, male. XY, male. So what are the chances of this couple having a baby girl, right? We have the ratio is 2:2, which is 1:1 simplified. So the chances are 50% chance. If you're good with cramming, you can cram this. It's going to be simple. If they talk about how gender is determined and they ask you to show with a genetic cross how gender is determined, you just write just like this. Nothing, you don't change anything. You just cram this and then you put it down, you write it down when they ask you to use a cross and show how gender is determined, right? The alleles don't change, they remain XY for males, XX for females. So this question might also come this way. Use a genetic cross to show how gender in human offsprings is determined by the sex chromosomes of the parents. If they ask you this question, what you're going to write is the same thing that I've just written there. F1 phenotype, genotype, meiosis, gametes, till phenotype down there, and you're going to substitute male times female, XY times XX, X, Y, and X, X, and you write the genotypes XX, XX, XY, XY. You write the phenotypes female, female, male, male. That's what you're going to write. So this question is always simple because you can just cram this, and then when they ask you about how gender is determined and asking you to represent it using a cross, a genetic cross, You just write it. So let's move on to inheritance of sex-linked characteristics. What are sex-linked characteristics? These are diseases, right? So these diseases are called sex-linked characteristics. But why are they called sex-linked characteristics? They are characteristics or traits that are carried on the sex chromosomes, right? So, for an example, hemophilia is a sex-linked hereditary disease that occurs as a result of a recessive allele on the X chromosome. For an example, on males, remember the sex chromosomes for a male is XY, right? X and Y. So if you see a recessive allele on the X, a recessive allele H being an exponent on the X of the male's sex chromosome, it means that that man has hemophilia, because they're saying hemophilia is a sex-linked hereditary disease that occurs as a result of a recessive allele. So for a man who is affected by this disease, his sex chromosomes would be X exponent small h and then Y. The Y doesn't carry anything, only the X, because this is what sex-linked characteristics or sex-linked diseases. So a man who doesn't have this disease, because it is caused by a recessive allele, a man who doesn't have it will have a sex chromosomes which are X exponent capital letter H and then Y. The capital letter H, it shows that the man does not have the disease. He does not have the recessive allele H. So let's look on the side of women. Women have sex chromosomes XX. So if this disease is caused by a recessive allele H, a woman who is affected would have X exponent small h, X exponent small h, right? So the woman needs to have recessive alleles on both X's for her to be affected. And then for a woman who is not affected, she would have X exponent big H and X exponent capital letter H. That woman would be normal. So the capital letter H, it shows that the woman is normal. All the X's does not have small h. And then again, a normal woman can also have an X, the first X exponent big H, the second X exponent small h. Just because there's a small h doesn't mean she has the disease, but we call her a carrier. She carries the disease, but she doesn't have the disease. She can have kids that have the disease because of her being a carrier, but she is normal because the big H overrides the small h, right? The dominant allele overrides the recessive allele. This is what I was explaining in the previous videos. Right, so let's look at the next question. It says color blindness is a sex-linked hereditary disease that occurs as a result of a recessive allele on the X chromosome. So a man who is affected by this disease will have a recessive allele on the X, right? So color blindness, let's say the allele is B, right? So the man who is affected would have a sex chromosomes which are X exponent small b and Y. Remember, the Y does not carry anything because these are sex-linked characteristics. And a normal man would have X capital letter B and then Y. The capital letter B tells us that the man does not have the disease because it is caused by a recessive allele, not a dominant allele. Remember, recessive means small letters. Dominant means big letters. Now let's go on the side of women. A woman who is affected, she needs 2 recessive alleles on the X's for her to be affected by the disease. So X, the first X would have an exponent of the small b, the second X would also have the exponent of the small b for her to be affected. And then a normal woman would have X exponent capital letter B, X exponent capital letter B. Another genotype of a normal female would be X capital letter B, and the second X with a small letter b. This woman, we call her a carrier, meaning she can transmit the disease. Her children can have the disease because of her recessive allele, but she is normal. She is a carrier, or she is heterozygous. So let's move on to the next one. Moyamoya is a sex-linked hereditary disease that occurs as a result of a dominant allele. So color blindness is a sex-linked characteristic, also hemophilia, right? But then the examiner might come and tell you that the moyamoya is a sex-linked hereditary, although you haven't learned about moyamoya. He might come again, the examiner, and say gonorrhea is a sex-linked characteristic. You've never heard of gonorrhea, but you just have to treat the question as we treat color blindness and hemophilia. So now moyamoya is a sex-linked hereditary disease that occurs as a result of a dominant allele on the X chromosome. So this one is caused by a dominant allele, right? It is not always that sex-linked characteristics are going to be caused by recessive alleles. They can also be caused by dominant alleles, by capital letters. So now let's talk about color blindness. They might come and say color blindness is a sex-linked hereditary disease that is caused that occurs as a result of a dominant allele on the X chromosome. The allele being capital letter B, right? It is not always that they'll tell you it's caused by a recessive allele, right? So if they told you it is caused by a dominant allele, a man who is affected would have an X and a capital letter B, because why? It is caused by a dominant allele, and then the Y doesn't carry anything. A man who is normal would have an X and an exponent small b and then Y. The small b means that the man is normal. He doesn't have the disease. Now let's look on the side of women. A woman who is affected would have the first X with exponent capital letter B and the second X with exponent capital letter B. So the capital letter B shows that the woman is affected. Another woman who would be affected would have an X capital letter B and X small letter b. So why is she affected although she has the small b, the recessive allele? Because the big B overrides the small b, right? The phenotype of the woman is going to take the dominant allele, the capital letter, so the woman is going to be affected by color blindness. So a woman who would be not affected would have X with an exponent small b, X with an exponent small b. That's a woman who wouldn't be affected because this is caused by a dominant allele, by a capital letter. So now let's look at this question. Hemophilia is a sex-linked hereditary disease that occurs as a result of a recessive allele on the X chromosome. Right, for an example, an X would have an exponent of the small h. So a normal father meaning what would be his genotype? It would be X with capital letter H on the top and then a Y. And a heterozygous normal mother. Heterozygous meaning a carrier, a woman who is normal but he is carrying the recessive allele. So her genotype would be X capital letter big H and an X capital small letter H. So what they're saying is that they have children represent a genetic cross to determine the possible genotypes and phenotypes of their children. And then again you're going to write P1, and then next to P1 you write phenotype, and then you write genotype, you write meiosis, gametes, fertilization, genotype, and phenotype. And then you need to know these things by heart, P1 to F1, because nobody would give you in your exam. So for phenotype, you substitute, right, according to the statement. You substitute according to the statement. Phenotype of the father, he is normal. Phenotype of the mother, he is heterozygous or carrier normal mother. And the genotype of the father, because he is normal, he wouldn't have the small h, because this is caused by a recessive allele, a small letter. So the man would have X and a big H and Y multiplied by. The female is a carrier, is heterozygous. And then you write X capital letter H and X small letter h. And then gametes, you write genotypes as they are, and then you just put "and" in the middle of the alleles. And for fertilization, you write nothing as well as meiosis. And then genotype, how do you find the genotype of the children? You're going to take the first X that has exponent capital letter H, you combine it with the first X on the mother with capital letter H, you put them together. That is X capital letter H, X capital letter H. The second one is going to have the X, that you take the first X of the father, and then you combine it again with the last X of the mother. You're going to get X capital letter H and X small letter h. And then for the Y now, let's take the Y, we combine it with the first X of the mother. We're going to get X capital letter H and then Y. I told you we start with X, not Y. And then again, the last one would be Y again combined with the last X, right? The X that have a small h, and then we would have X small h and a Y. So those are the genotypes of the children. So what are the phenotypes of these children? The first genotype is X capital letter H, X capital letter H. That is a normal daughter, right? And then we have another one, X capital letter H and X small letter h. That is a normal daughter again, but she's a carrier as well. She carries the disease with her. And then we have XH capital letter H and then Y. That is a normal son. And we have X small letter h and then Y. So that is an affected son. So can you see that the woman is the carrier? So this disease mostly affect men because men only need they only need one allele. That only need one allele on the X, right? Because they have one X, they only need the allele on that X for them to be affected. But women need two alleles, right? For an example, if it is caused by a recessive allele, they would need two recessive alleles on their X's for them to be affected. So it mostly affect men, right? And then women are mostly carriers. They carry the disease with them, but they are normal. Thank you so much for listening. Don't forget to subscribe to my channel, and I would really appreciate